All right, we're going to go ahead and get started. If you don't have to restart your laptop, and it can wait until after class, do so. Otherwise, restart it and get logged back in. All right, we're going to go ahead and get started. This is your new Linear Relationships digital notebook that you should have already pulled up. I'm going to have you guys click on the first tab, which says 11.2 to 11.6. Go ahead and click on that, and that'll open up this week's lesson list, okay? Then you're going to go to today's lesson, which is November 3rd. At any point throughout this digital notebook, if you need to go back to home, that's what this little red button does. It'll appear all throughout the digital notebook, but it takes you home. Today is November 3rd, so I'm going to click on November 3rd. And there's going to be a number of things displayed for me. First is my EQ, or my essential question, which today my EQ is how can I use a graph to represent a proportional relationship. It'll have our lesson video, which will be uploaded in a little while today. Our lesson checklist, so you know what you need to complete for today, which is complete lesson notes, complete checkpoint 1, and work on proportional relationships and percentages. Then you'll also see the quote of the day down here. Today it says, by voting, we add our voice to the course that forms opinions and the basis for actions. And that's because today is election day. Then down here it says our notes and slides. If you click 1, it'll give you a copy of our notes. If you click 2, it'll show you the slides so you can look through the slides for today. I need every single person to click on 1 and make a copy of their notes. I'm going to give you about 1 minute to do so we're ready to get started. Click on 1. All right, let's go ahead and get started. You should all hopefully have the notes open. I'm going to open up the slides for today. We're going to go ahead and get started. As we move into this new unit, which is linear relationship, I am going to first review proportional relationships because we're going to build off our proportional relationships knowledge to take us into linear relationships. So let's do a little practice activity, okay? And this is called moving through representations. And I want you to look at this representation I'm going to show you in just a second of a ladybug and an ant. A ladybug and an ant move at constant speed. The diagram with tick marks shows their positions at different times. Each tick mark represents 1 centimeter. All right. So what I want you to do right now is I want you to go ahead and look at our diagram. And based off our diagram, I want you to take 2 minutes to record anything you notice that's going on here. Okay, so take about 2 minutes to do that. All right, so let's talk about some observations we might have had. What I want you to do is in the chat, I want you to type your observations. You can either type it privately to me or you can type it for everyone to see. But what is something you notice about here? Please make sure you're typing your observation so that way I can record you as present for the class today. Good, I'm seeing some good observations coming in, but I still need a few more so I can make sure everyone is counted as present for today. All right, so here's a couple things that have been noticed, okay? Everyone's noticing that the ant is moving faster than the ladybug. Okay, a couple of people have pointed out that the ant is moving at a consistent rate. He's moving 1, 2, 3, 4, 5, 6 ticks, which is 6 centimeters per 2 seconds. So that's like 3 centimeters a second. Okay, everyone has also noticed that the ladybug is moving at a constant rate, and she's moving 1, 2, 3, 4 centimeters per 2 seconds, which is like 2 centimeters a second. Okay, those are all observations that you guys have made. Very good observations. So now I'm going to give you a graph for it. Okay, and I'm going to tell you that lines U and lines V represent the two bugs. I want you to look at it and which one you think represents which bug. Okay, this is our distance traveled at the bottom. So this line represents distance traveled, and this line represents time. Which line do you think is which bug? Is U ladybug or the ant? Is V the ladybug or the ant? Take about 1 minute to figure that out. All right, so some of you guys might have already been able to notice. But if you look, you can tell which one is the ladybug and which one is the ant, because we know that over time, the ant moves more distance in less time. So if we look at the distance here and we wanted to look at who traveled 3 centimeters the fastest, well, according to this, V moved 3 centimeters the fastest. So which one is going to have moved 3 centimeters the fastest? The ant is. So V is going to be your ant's line, and U is going to be your bug. So that's your ladybug. All right, so then let's move on and see if we can't do the next question. How long does it take the ladybug to travel 12 centimeters, and how long does it take the ant? See if you can use the graph to help you. I'm going to give you about 2 minutes to try it. Go. Use the graph to help you. Where are my centimeters? How would I find out where 12 centimeters is on my line? Use the graph to help you. All right, so let's go over how you do it. So in order to find out how much the ladybug travels or the ant travels for 12 centimeters, how much time it took, I'm going to go ahead and look at my graph. Since this says distance traveled, I know that I just need to count 12 of these to find out where the time in seconds go. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now I'm going to trace up this line so I can see where my line hits for the 12. Okay, so this is where it hits for the ant, and this is where it hits for the ladybug. So now to figure out the time, I just got to trace it across and count my time. So that's 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. So for my ladybug, okay, which is going to be LB, it took her 6 seconds to travel the 12 centimeters. But for my ant, it's 1 second, 2 seconds, 3 seconds, 4 seconds. So as you're looking at doing this, you're probably thinking, wow, this would have been a lot easier had these been labeled on the axis. This would have been a lot easier if this had said 1, 2, 3, and so on and so forth. So what I want you guys to do now is label your axis. Okay, so on your note page, I want you to label your axis. The way you're going to do that is by double-clicking the graph on your note page. It'll bring up the draw feature and allow you to label your axis. Take about 2 minutes to label your axis. All right, so let's label our axes. So if we labeled our axes across here, the centimeters, we're going to label by 1. So we'll just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Then on this side we have 1, 2, 3, 4, 5, and 6, and 7. So now that we've labeled our axes, let's go to problem number 4. And problem number 4 says, mark and label the point on the line that U and V represent the time and position of each bug after traveling 1 centimeters. So this is just like what we did before with the 12 centimeters, but this time we're doing it at 1 centimeter. We're simply going to draw a point right at 1 centimeter for each line. So I'm going to follow the line up and draw a point for each line. So there's my point for my first line, and there's my point for my second line. Using that, I can tell that the ant hit 1 centimeter at probably around 1/4 of a second. But the ladybug, it took about half a second to get to 1 centimeter. All right, so then let's move on to a practice problem. Now that we've seen how graphs can help us really analyze to look at different parts of a proportional relationship, let's talk a little bit more about it, okay? So graphing is a way to help make sense of relationships, but a graph of a line on a coordinate axis without a scale or without labels is not very helpful. Make sure you're filling this out in your note page. I'm going to give you a few more moments to do so. All right, so let's look at why having no axes labels or labels on our coordinate grid can be a problem for us. So I want you to read this problem here. It says that we know that on a longer bike ride, Kieran can ride about 4 miles every 16 minutes, and Mai can ride about 4 miles every 12 minutes. Here are the graphs of these relationships. So here's my graph. What can you tell me based off this graph right here? Take about a minute to look. Okay, using this graph, can I tell which one is Kieran and which one is Mai? No, because I don't know if this is distance and this is time, or this is distance and this is time. And depending on where distance and time is, it changes which one is Kieran and which one is Mai. Can I tell you which one rides faster based off this graph? No, because I don't even know which one is which person. Can I tell you where they would both be after 24 minutes of riding? Can I tell you how long it'll take them to reach the end of the 12-mile bike path? No, I can't answer any of these questions because there is no labels on my axes. Please make sure you're typing these questions in your notes under the questions that we can't answer. I'm going to give you a few more moments to do that. All right, so let's try it a little different. Let's add labels to the graph. Now that I've added labels in the graph, look at it again. Take a couple more moments. Okay, this graph, if you scroll down on your thing, you should not need to add numbers to it anymore because this is labeled on your notes. take a few moments and look at the labeled graph on your notes. What can you tell me now?
I'm hungry.
All right, so now that you've looked at the graph, you should be able to draw a few conjectures. You should be able to answer those questions now that we couldn't answer before. So let's revisit those questions. So here's our first one. Which graph goes with which rider? Well, let's remember what the problem said. The problem said that Kieran rode 4 miles in 16 minutes. Okay, so Kieran was 4 miles in 16 minutes. That means as a point, we're going to have a point that is called 416. So now I'm looking for which graph has a point called 416. This one does. So this top graph here is Kieran. While she went 4 miles in 12 minutes. Okay, so that means her point is going to be 412, which means that this one right here is because of the point 412. Oops. Make sure you're writing these into your notes. You've labeled which one is 412, which one is which one is Kieran. And I can tell because of the points. So let's go to our next question, which is, who rides faster? Well, if I look at the different points here, I can tell that Mai is faster because she is able to get to 1 mile in 3 minutes versus Kieran, it takes 4 minutes to get to 1 mile. And Mai gets to 4 miles in 12 minutes versus 16 for Kieran. And 10 miles in 30 minutes versus 40 for Kieran. So that means that Mai is the faster of the two riders. Okay, so then on to our next question. If Kieran and Mai start a bike trip at the same time, how far are they after 20 minutes? So now we have to use this graph to help us figure out where they're at after 20 minutes. So if we look at our time here is on this side right here. So I've got to find time on here and connect it to its point on each of the lines. I can see that these are moving up by 8 every 2, which means by every 1 they're moving up 4. So this is 4, 8, 12, 16, 20. Okay, so at 20 is where I want to know where they're at. So if I look and I draw my lines, this is where Kieran is at 20, and this is where Mai is at 20. So now I'm going to draw my lines down to figure out about where they're at. I can see that Kieran is at about 5 miles because that's what would have been here at 20 minutes. But my is a little less than 7. Okay, I use that just by tracing my 20 line and figuring out where it intersects. So, based off the points on the graph, Kirian is at 5 miles and 20 minutes, and Mai has biked a little less than 7 miles. Let's go to our final question. Okay, how long will it take each of them to finish? So just like below, where I talked about how we had to trace from 20 minutes to figure out where it's at, this time we have to trace from 12 miles. Miles are down here, so I'm going to trace my line on up, and I'm going to see where it intersects. So it intersects right here and right here. So now I'm going to trace over to the side so I can figure out what the time is. Okay, so that's 4, 8, 12, 16, 20, 24, 28, 32, and 36 for the first line. Since this first line we already determined was Mai, that means Mai is 36 minutes. Okay, then I have to go across for Kirian. And when I do that, I get 48. So in order to finish the 12-mile ride, it took Mai 36 minutes and Kirian 28. So using this graph, it has helped us to really be able to analyze this and use these relationships and identify where different things and how different things pass and make predictions based off of the relationships. So now what I need you guys to do is go to Summit and complete checkpoint 1 for the linear relations unit in Summit. Okay, that is your homework, so go ahead and start it now. You guys have about 15 minutes in class, so that's plenty of time to get it started, and I'm here for chats.